This video will work through problem 15.2 from Gapenski's Healthcare Finance, 6th edition. Okay, so in this problem, we are asked to look at a project with 3 probabilities, and we have 5 years of values plus a, so they're constant level of cash payout, except in year 5 where they get a salvage value added on of $10,000. So the corporate cost of capital is equal to 10%. And so the question is, what is the project's expected, i.e. base case NPV, assuming average risk? So the average risk for this organization is an average risk project in this organization would use the organization's corporate cost of capital, which is 10%. So we'll just calculate the NPVs for each of these possible outcomes for the project. So the first one, we'll calculate the NPV. We'll use the NPV formula. We'll use the corporate cost of capital, and then the cash flows, and then add the investment cost. And we see that the first one is a loser. And let's see how the other ones do. All right, let's just clean this up a little bit, get rid of our decimals. And so the NPV for each, the NPV for the project then is just the sum of the weighted average of these, each of these. So take 0.2 times the NPV for that project plus 60% chance times 19,000 plus a 20% chance times 57,000. And that gives us the weighted average of the projects, which gives us 19,932 and some change. Right, round up to 19,933. So what are the project's most likely, worst case, and best case NPVs? Well, the most likely is 19,933. The best case is 57, and the worst case is 17. What's the project's expected NPV? Well, okay, so I just did a scenario analysis. I'm going to flip, now I'll flip to the other way you could do this, and you get the same result. Is you take the weighted average of each of these lines, create a average or expected column, let's say. So you take 0.2, let me just lock that reference, 0.2 times 100 plus 0.6 times 100 plus 0.2 times 100. Scroll down here, and then we do the NPV using these values. And notice that we get the exact same outcome. So so in this version, we're averaging, taking the weighted average of each year's cash flow, and then we calculate the NPV based on the averaged cash flows, and then we wind up, with the same outcome. Here we did the scenario analysis version. So I actually did part C first, and now this column represents actually part A. My default is to do it using the scenario analysis perspective, and as you can see, the result is always the same. It doesn't matter which way you do it. So that's kind of reversed A and C. What's the project's standard deviation of NPV? Okay, so this requires looking at the NPV, the expected project NPV versus each of the expected NPVs for each of the possible states. So we want, first we get the variance, and that's going to be equal to the weight times the difference between the expected NPV for each of the scenarios and the overall NPV squared. So we just do that for each of these. And that one, of course, is going to be 0. And then the standard deviation is just the square root of the variance. Wrong character, need the caret, not the ampersand. And so you get the standard deviation of 23,975. And then, so finally, assume that Hayward's managers judge the project to have lower than average risk. Furthermore, the company's policy is to adjust the corporate cost of capital up or down by 3 percentage points to account for differential risk. Is the project financially attractive? Okay, so without adjustment, the NPV is greater than 0. So that tells us that the project is attractive because it has an NPV greater than 0, which means that the project will return more than a 10% return on investment. If they've decided that the project has lower than average risk, all I have to do is reduce the corporate cost of capital. When I do that, what happens is my NPV is actually going to go up because I'm actually reducing the discount rate that is going to be applied to the cash flows. So if they adjust by 3 percentage points down, because it would go down because this is a low risk, we're going to go from 10% to 7%. And when I change this, because this is Excel, and I've programmed it already to incorporate that 10%. You can see that my NPV goes from 19,000 to 30,000, and makes it, not only is it a viable and attractive project at 10%, but it's an even more viable and attractive project at 7%.